continuación del trabajo de máster de Francisco Ferro, con el trabajo titulado Use of Animal-borne Telemetry Data for the Characterization of Coastal and Oceanic Waters in the Eastern Ocean.
Thanks for the presentation. Good afternoon, everyone. And now, with the permission of the board, I will start to present my master thesis entitled Use of Animal-borne Telemetry Data for the Characterization of Coastal and Oceanic Waters in the Eastern Atlantic. So, for the content of this presentation, I divide up the paperwork in the introduction, when I will explain the stability data technique, the numerical models, and the animal-borne telemetry technique. And then with that, the study area that we have. And finally, with all this theoretical framework, how we arrive to the altitudes of this presentation, of this work. Then the materials and methods that we use, so the different numerical models, tags, and animals that we use for this study, and then the results that we obtain using this. The discussion with other authors of the following results, and the conclusions that we obtain in this study. I will finally finish with the impact and the future works that we have with this research line, and the reference that we use for this presentation. So, for the introduction, and I said I will start with the satellite products. So this remote sensing technique changed the way that we see the ocean on the last century. And this allows us to see all the ocean in one way. Here we have a representation of a satellite in a high altitude with the different pictures taken for the ocean. Here we can see all the ocean in one way. But here we have some limitation to the surface layer, because this technique only allows to us to see the surface layer of the ocean. For that, more techniques were developed to understand and to go deeper in the ocean and study all the dynamics. Other methods that we have are the numerical models. The numerical models are a way to use the theory to understand the dynamics of the ocean. Here we have a good representation of what is a numerical model and how it works. Here is the weather forecast modeling, and we have the dividing of the grid on latitude and longitude, and here the different layers. In this case for the atmosphere, but also we can have these layers for the ocean. And here we have the different variables that we can study, and here variables of the atmosphere. In our case, can be the ocean. This allows us to see the subsurface structure and the dynamics of the ocean. But this is only theory, so for being more accurate, we can use some algorithms to put all the data of the satellite and the in-situ data to be more accurate of what happened in this part of the ocean using the numerical models. One in-situ data that was developed in the last decades are the animal-borne telemetry. The animal-borne telemetry technique is summarized in the following picture for the ocean, and here we have the different marine animals that we can use, as the flying birds, the marine mammals, sharks, penguins, turtles, and fish. Depending on the latitude that we have, we will use different animals. Each animal can have different values of the environment, as the flying bird can have the wind direction or the wind speed, and the other ones can have the essential ocean variables, as the temperature or the salinity. In this case, all this data is sent to the satellite and then arriving to us, to the end users, the researchers. And we can use it to do some operational centers or the GOOs networks that put all this data together. One of the animals that is interesting to see in this study are the sea turtles for this technique. The sea turtles are cosmopolitan animals. This means that they are worldwide. So they're standing around the globe, and here we see that are marine reptiles. That means that depends on the temperature of the environment. So these animals will move differently depending on the temperature. And nowadays we know that there are 7 species of sea turtles. For all these species, one that is interesting to us to study are the lower head sea turtles. The following turtles, known as careta, are turtles that depend on the seasonal changes. So they will move with the temperatures and the change on the seasons. They also go long migration distance distance patterns, and that do dives until 200 meters. So around 200 meters is the maximum dive that they have these animals. This means that they are ideal for this technique, also for the distribution that has in the ocean. As I said, they are worldwide, and in particular, the careta has this distribution. Here we can see all the areas they can cover, and in the following map we see the study area. The study area, known as Canus, Canary Wellness System, is delimited by the Cape Finisterre in the northern part and the Cape Blanc in the southern part. This is the latitude limitation, and in longitude depend on the outflows. Here inside of this map we have the main currents, not the source currents, and the Canary currents that work to the south. Inside we have the islands on this zone, the Azores Island, Madeira, and the Canary Islands. And here we have some representation of eddies that are in the southern part of the island, that are typical of this zone, in a cluster way, in an anti-offside way. And in this part we have a little zoom on one of the parts that one of our tortoises will stay for a long time. So, with all this theoretical framework, we arrive to the objective of this work, to utilize the animal-borne telemetry technique to describe oceanographic structures and their interaction with the sea turtles. Then we can define the operational boundary of the sea turtles of physical samplers, and we can compare the telemetry data taken in situ with the operational numerical models to validate the performance in the northeast of in the eastern Northland. So, the materials and methods that we use for this study are the following. Starting with for the tags. So here, I will say that the tags are the devices that stay in the animals in a respectful way and send the data to the satellite. Here we have this table in the right part, and in the left part the picture of each tag. Here are the tags that can be used for the hull shelf or the hard carapace torture. We have all these possibilities, and finally we choose to use the manufactured by wildlife computers that are the Splash series. In particular, the Splash Fast-Log series. This model was identified as the ideal for this study, and we configure them for changing this remote this temperature sensor range from -40 to 60 to put it for the study area of Canus, so between 18 and 28 degrees. This allows us to have more resolution in this study. Then we have the different tortures that were used, starting with Apuy. So Apuy was a wildlife animal, a joint wildlife animal that comes to the Fuerteventura Rehabilitation Center on September of 23. Was interested by eating 2 hooks with the fishing nets and some plastic inside the stomach. Also has here a little damage, maybe did by a shark bite, and outside here we have the tag attached to the turtle. And this turtle was released used with 30.6 kilograms of weight. Then we have the second turtle that we use, that is Albi. In this case, Albi was a captivity-born animal, a chef with 15 years old. Was catched on the Cofite Beach in Fuerteventura on November of 2007. This ex was relocated for the Boavista Island in Cape Verde to the Cofite Beach in Fuerteventura. This is a part of a project of expanding the nesting areas of the lower sea turtles in the Macarena Sea. This was made by the governments of Cape Verde and Canary Island together. And this turtle was released on the same beach that we were catching, in Cofite Beach, weighing 72 kilograms. And the numerical model that we used was the forecast product, called the Global Ocean Physics Analysis and Forecast, in this case taken by the Copernicus Marine Service. And this allows us to see the sea surface temperature, so the SST, so the first layer of the ocean, and the subsurface temperature, so more than 50 meters. And then this was processed using the MATLAB software of MATLAB 23. The results that we obtained using these tags, models, and techniques and the following. So start for the torture. First of all, we can see how here we have the name and the sex of a food was not determined. This is because the food turtle was wildlife, so it's typical with the turtles taking the sex when they come to the rehabilitation centers. In the case of algae, it was a female, identified because it was a captivity-borne animal. Then we have the start location, both of them in Oceanography Island, and then the end location that we will have for a food, Oceanography also in another place, and algae, the western coast of the Sahara, of the Western Sahara. Then we have the effective distance. This is the distance between the starting point and the end point. So this distance will be less for a food because it remains in Fuerteventura, and more for algae because she did a long migration. Then we have the cumulative distance. So this is all the distance that was streamed by the torture. And then we have the chart stability radio. This radio is between the effective distance and the cumulative distance. And here we have from the starting point to the end point a red line. So this will be a chart stability radio of 1 because the effective distance and the cumulative distance are the same. But in another case we can have a circle. So we have that the effective distance is 0, but the cumulative distance is more. So with this radio, we will see how algae has more a value higher than a food. So that means that she did more line migration. Then we have the result of a food with the map outside and the temperatures taken on the downside in this animation. Here we can see how a buoy has a coastal behavior. So stay around the Fuerteventura Island almost all the time. And we see some concentration of points in the last part of the journey, in the eastern part of Fuerteventura, and in the northern part. So between Fuerteventura and Lanzarote, in La Bocaina channel. These are the most concentration of points this journey. And also we can see the shift on the temperature here between autumn to winter, so the warm temperatures to the coldest temperatures, and how she stayed in the first 100 meters, and this is almost on the mixed layer, almost all the time. Then we have the temperature comparison, so in the first layer with the numerical model, we see here the red circles are the temperature taken by the turtle, and the black dots are the temperature taken by the numerical model. Here we see how this scarcity of data we have for the numerical model because it's near to the coast. So go out of this resolution that the numerical model has, go falling out of this spatial domain. And when we make the correlation, we have a good correlation of 97, but when we see how much data we have few data, so we can see that we can say that this is a good correlation for the scarcity of data in this case. When we go deeper, so at the subsurface layer, we have less data of the numerical model. And in this case, also, we have a good correlation of 96, but when we see the data relation, there is no data to put between the points, so it's almost not correlated. Then we have the results of algae, and we see how in the standard point she took a circle and another circle. This is an eddy in the southern part of the Canary Island. And finally going to this part of the Western Sahara. Here, on this eddy, how was taken by turtle algae, we can make a zoom here and see more the difference between the temperatures. And if it's not clear enough, we can interpolate this and see the internal structure of this eddy. Seeing how it was anticyclonic and put the warm layers of the temperature of the ocean in the deepest layer of the ocean. And then we see how here we have a thermal front or upwelling front staying in this area, in the upwelling area. And how she stayed almost all the track there. She stayed there and taking all these temperatures, so all the temperatures. There we will have the temperature comparison of the subsurface of the surface layer, and here we have more points. We have a division in the first part for this overwhelming front. So the thermal front, we see how it's divided points for the high temperatures to the lowest temperatures, and we see how almost here the forecast product has except the layers. So the data that we have almost all the time, the forecast product is outside of the temperature taken by the turtle here. And when we make a correlation of this, we will have a high correlation of 93, but we see clearly how we have some points in this part and some others in the other part. So for being more accurate, we need to divide this in two. So when we have all the correlation in one part, we can have the first part as 0.74, that is higher than high enough. And when we put only the part of the overwhelming zone, we will have 0.62 of correlation, so almost not correlating these points. Then when we go deeper, things go worse for the numerical model, and we see how the overestimation in all these parts of course in the overwhelming zone is higher, and the correlation is also high, so in HC6, but we need to do the same again, dividing in two, and see how in the first part we will have a correlation about 3. But then when we put only the overwhelming zone, we will have a correlation of 0.11, so almost not correlating these points. Finally, for the discussion, I will start with each turtle, taking the main result of each one. And for a foil, she frequently the same area, so it allows us to see the coastal behavior of the waters in the island of Fuerteventura. And this coastal pattern seen on the foil as a wildlife animal is a common pattern seen by Walton in 2003 as a juvenile narrative stage that they have, this turtle have. And we see how the forecast product scarcity and limited comparison with the in situ data. So all this data taken by the coastal zone of Fuerteventura was only possible by the animal-borne telemetry technique. Then for the turtle algae, we see that despite not being a activity-borne animal, we have a good inspiration, a good pattern influenced by the outwelling areas and because the currents of the study area, and show the possibility of capture a mesoscale eddy typical of this region. And we see how something this eddy, this with anticyclonic rotation that transport this warm water to the deepest layer. This was possible by this turtle. And it's important to understand how the changes on the temperature that this turtle see will change the way that this animal migrates, because they are exothermal animals. So will change this way of migration. And for the conclusions, I would say that this study presents a novel way to study the area canals, taking the numerical models and the in situ data taken by the animal-borne telemetry. The food observations of the Fuerteventura Island and coastal zone allowed to see the change on the SST temperature shifting about 2.5 degrees between autumn and winter. The opportunity of the structural algae of characterize an eddy in this part is a way to see how potential is this technique, to see all the structure inside of the eddy. And then discrepancy about 2 degrees for the forecast product at the in situ measurement often show that the model overestimate all these temperatures, also in a surface and the subsurface layer of the overwhelming areas. And it has been demonstrated that the lower sea turtles are ideal candidates for the animal-borne telemetry technique, making long-distance migration and arriving to take data about remote areas of the coastal zones. And furthermore, this study offers a new insight on the migratory patterns of a common animal on this region. And I want to finish these presentations showing some impacts and future works that I have with using this research line. I have part on this research line. First of all, I have the possibility of staying in the EU 24, showing some results of this research line in a poster, and also speaking on the theme of this year, showing how the telemetry-borne technique works and how it works with the churches. The idea is to put all this work in a future paper in Frontiers magazine. And finally, I will move to Italy, where I will work with the Data Mare group to the nesting areas and the help with this part on the Tuscany, on the coastal of Tuscany. And I'm speaking with the strong project that they work with the same turtles and the same track to understand how the change on the temperature of the Mediterranean Sea affect to these turtles. These are the references that I used for the presentation, and thanks for your attention.